Let's start solving the exam questions for this second lesson. The first of which is this one over here. This is from an exam from spring 2014, question paper 11, question 7. It says the coordinates of points A and B are A2 and 3B, respectively, where A and B are constants. The distance AB is square root of 125 units, and the gradient of the line AB is 2. Find the possible values of A and B. All right, so you are given the coordinates of 2 points, but the information that you are provided is incomplete. You don't know the x-coordinate of point A, and you don't know the y-coordinate of point B. So you have two unknowns here, which are the things that you are being asked about. So you have two unknowns. What do you need to figure out the values of two unknowns? You need two equations. So what information is provided here that will allow you to set up two equations? You are given the distance AB. So if you use the formula for the distance between 2 points, plugging in these values and equaling it to square root of 125, you have one of the equations. And the other one is the gradient. You are also given the gradient. So if you use the formula for the gradient of a line given by 2 points and equal it to 2, you'll have the second equation. Do simultaneous equations, and you will be able to answer the question. Let's see. That's what I did over here. I always advise to write down the numerical information that you are provided on top, and also what you are being asked. And then it's going to be clear what you have to do. Here is for the gradient. The gradient is the difference in height, so b minus 2 over 3 minus a equals 2. And the formula for the distance between 2 points, b minus 2 squared plus 3 minus a squared equals square root of 125. You solve this, you get rid of the square roots on the bottom, and you solve that on top. Then do the necessary algebraic manipulation. Here you get the value for b, substitute b over here. I use substitution, I think it's the best method in this case. I set up this quadratic, divide the whole thing by 5. I realize that this is the product of these two factors, and I first get the value of a as being minus 2 or 8. Then I substitute where I left the equation over here. First a by minus 2, and I get the value 12, and then by 8, and I get the value minus 8. So the two possible values for a and b are these: a minus 2, b 12, or a 8 and b minus 8. Overall simple question, yielding anyway 6 points. Second one, again, is increasing in difficulty. It's this one. This is from winter 2013. It's paper 11, question 7. It says the point A has coordinates minus 1, 6, and the point B has coordinates 7, 2. So here you are given all the information about the points. Find the equation of the perpendicular bisector of AB, giving your answer in the form y equals mx plus c. Okay, let's let in what they are actually asking. You are given the coordinates of 2 points, and you fully know the values for these coordinates. You are asked the equation of the perpendicular bisector of AB. So what does this mean? First of all, what is a bisector? A bisector, as you might remember, is a line that cuts another line in 2 equal parts, right? So if you have points A and B, and if you have the line connecting them, let's say it's this pen, the perpendicular bisector is a line that is perpendicular to this line and cuts this in half. So if it cuts it in half, what is this point going to be? This is going to be the midpoint, right? So you will have to use the equation for the midpoint to know the equation of the perpendicular bisector. In order for you to be able to provide the final answer, you need what? You need the gradient and you need the y-intercept, right? So let's keep in mind about the midpoint over here. But let's go to the fundamental thing, the gradient. How are you going to get the gradient of this line? You cannot get it directly. You will get it indirectly by getting the gradient of this one first. And getting the gradient of this one first is easy because you have the coordinates of the 2 points. So once you have the gradient of this one, getting the gradient of a perpendicular one is going to be easy as well, because the gradient of this one times the gradient of this one equals -1. Remember, they are perpendicular. So now you are going to know this already. All you need is to get the value of C. What is the procedure for you to get the value of the y-intercept of a straight line once you know the gradient already? You just have to plug in on y and x the coordinates of a point that you know that belongs to the line. What is this point? Is the midpoint that we were talking about a little while ago. So you need to get the coordinates of the midpoint. Once you have them, plug the x coordinate over here, plug the y coordinate over there, and solve it for C, and you have the y-intercept. Let's see how this is done. Anyway, before you actually, once you are solving exam questions particularly, before you actually pick up your pen or pencil and start solving it, you have to figure out in your head the strategy that you are going to follow in order to solve the question. What is the strategy is what I just did, thinking of how to get to the final answer using the information that is provided in a question itself. Now that I know what to do, it's just a matter of putting in paper all the things. So here the information, what I want, and first I get the equation, the gradient of the line AB is -1/2. So the gradient that I want is -1 over this, which is 2. Or in other words, this times this equals -1. So this one needs to be 2. The perpendicular bisector crosses AB on its midpoint. And what is the midpoint? I'm just using a formula for the midpoint, and I get the value 3, 4. So I know that the equation that I want has this form, y equals 2x plus c. I need to know the value of c, the y-intercept. So I put the 3 on the x and the 4 on the y, and I get the value of c is -2. So what is the final answer? Y equals 2x minus 2. This is the equation of the perpendicular bisector of line AB. Let's look at the second part of the question. No, there was no, not this one. It's this one. A point C on the perpendicular bisector has coordinates PQ. The distance OC is 2 units, where O is the origin. Write down 2 equations involving P and Q, and hence find the coordinates of the possible position of C. Let's read again, now thinking of the strategy already. You should first skim through the question, understand what is there, and then read it again in order to start figuring out the strategy that you are going to follow to answer the question. So, you have a point C on the perpendicular bisector that we just got. We know the equation of the perpendicular bisector. So we are now talking about a point C over here that has general coordinates P and Q, could be anything. But you know that the distance OC is 2 units, where O is the origin. So in relation to the origin, you know that the distance, if this is a perpendicular bisector and here is the origin, the point C is such that the distance from C to the origin is 2 units. So this information is stucking this point C in place. So you need to write down 2 equations involving P and Q, and hence find the coordinates of the possible positions of C. 2 equations involving P and Q. Let's see here. First of all, if you know that C belongs to the perpendicular bisector, so if you plug in the coordinates of C as they are provided to you, PQ, on the equation, you already have an equation relating Q to P. Don't forget, what is this? This is this equation. If you put P over here and Q over there, you already have an equation. If you want to know P and Q, you have two unknowns. How many equations you need? You need two. So here you have already one. And then what you know that the distance O to C equals 2, right? So if you apply the formula for the distance between 2 points, what do you get? You get something as simple as this. The distance between 2 points, and forget what one of the points is point 0, 0, right? So the equation is simplified into this. Simplify it even further, and here you have a second equation. Two equations, two unknowns. So what you do? Simultaneous equations. This one is already prepared for you to make a substitution here on Q. If Q equals 2P minus 2, you can plug it over here. Square it. You'll have a quadratic with no term in C. So you can just factorize P, and you get the values of P as 0 or 8/5. When P is 0, you substitute it over here, and you'll know that Q is going to be minus 2. When P is 8/5, if you substitute it over here, you'll have value of Q of 6/5. So here you have the two possible pair of values, the two possible coordinates of P and Q. I think that is it for, you have the two equations. In terms of what you would have to provide as an answer in a paper. I always advise to underline, here I highlighted, the answers that the question is asking. So here are the two equations that you were being asked. And finally, here the coordinates of the 2 points. You can write them as P and Q, and put it as 0 minus 2 and 8/5, 6/5. Let's go to another exam question. This one is from a paper, Spring 2015, question paper 11, and it is question 6. The line with gradient minus 2 passing through the point P 3t, 2t intersects the x-axis at A and the y-axis at B. Find the area of the triangle AOB in terms of t. Okay, let's think of this again. So you have a line with a negative gradient. Negative gradient means what? Means that the line is like this, right? Imagine here, let's say that this whiteboard, this is going to be the y-axis, this is the x-axis. So you have something like this, in which, so a gradient of minus 2. And it passes on point 3t, 2t, okay? So this is now going to be not the x-axis, but the t-axis. You can already figure out something interesting here. For whichever value of t, the ratio of the height to the distance is 2/3, right? Substitute, for example, t by 1. Then what is point P? It's going to be 3, 2. If you substitute t by 2, then it's going to be 6, 4, and so forth, right? Which makes sense because the gradient is minus 2. And then the question is talking about the triangle. And what triangle is this? It's AOB. O is here, the origin. What is A and what is B? A is the x-intercept, so intersects the x-axis, this line. So A is going to be this point. And B is going to be the y-intercept, right? So now you have these 3 points. You have now here a triangle, is a right angle triangle, obviously. And you are asked about the area of it. What is the area of a triangle such as this one? Is base times height divided by 2. So all you have to get is this coordinate exactly over here, this one over here, and then you are set to answer the question. Here it is. Never mind this part over here. This is for sub-question 2. You have here the diagram I was just explaining using the whiteboard. So here you have the general equation of this straight line using the gradient that you were provided, the -2. If you use this general point P, 3t, 2t, and plug in the coordinates on it, what do you get? You get a value of c in terms of t that equals to 8t. So the general expression is going to be something like this. Y equals minus 2x plus 8t. Let me think about one thing. I told you something wrong a little while ago. I told you that this was now the t-axis. It's not. It continues to be the x-axis. The t is whatever other variable that is not represented over here. But whatever it is, the value of t, you apply to both coordinates of point P. Then the area of the triangle. What do you need to know next? You know that B is the y-intercept. So if it is the y-intercept, what is this point over here? Is this over here. The x-coordinate of any y-intercept is 0. The y-coordinate is what you see here on the equation of the straight line. What are the coordinates of point A? In order for you to get the coordinates of the x-intercept, you have to equal this to 0. So you equal it to 0, and you'll know that x is going to be equal to 4t. Again, for any x-intercept, the y-coordinate is 0, so the coordinates of A are 4t, 0. What is the area of the triangle? Again, is base times height divided by 2. This is already a 90-degree angle. So it's OA times OB divided by 2. So 4t times 8t divided by 2. This is 16t squared. The question again, find the area of the triangle AOB in terms of t. Here it is, an answer in terms of t. I forgot to highlight or underline this in green, but there it is, the final answer. The second part of the question is, the line through P perpendicular to AB intersects the x-axis at C. Show that the midpoint of PC lies on the line y equals x. There's a lot of information here. You should not start stressing because you have so many things condensed in a very short sentence. Let's break it down calmly as we go. So we have a line through P perpendicular to AB intersects the x-axis at C. What is AB again? AB is this line over here. So you have a line AB, you have another line through P perpendicular to AB. So is a line that is perpendicular to AB and intersects the x-axis at C. So we're talking about this line over here. All right? And you need to show that the midpoint of PC, what is P and what is C again? C is the x-intercept of this new line, and P is the point of intersection of this perpendicular line to the original AB. It lies on the line y equals x. How do you prove this? We're going to see it in a bit. Let's just get first the equation of this line through P and perpendicular to AB. If it is perpendicular to AB, you automatically know the gradient. If the gradient of AB was -2, the gradient of this new line is going to be -1 over that, which is 1/2. So the equation is like this for the time being. You don't know yet the coordinate or the value of the y-intercept, but you know one point that belongs to this line is point P. And P has coordinates 3t, 2t. So if you plug this over here and this over there, you get the value of C as being t over 2. So you can now rewrite the equation like this, all right? Or you can rewrite it like that. Anyway, you have already an equation. When y equals 0, you know that x equals minus t, right? What are you finding? You are finding the coordinates of point C. The coordinates of point C over here when y equals 0. See? So point C is going to be what? Where is it? It's over here. When y equals 0, substitute over here, you know that the x coordinate of point C is going to be minus t. Again, we are working in terms of t. For you to prove that the midpoint lies on the y equals x line, we first need to get the midpoint. And for that, you need the equation for the midpoint in terms of t again. So it's going to be 3t plus minus t over 2, and then 2t plus 0 over 2. And what do you get? You have tt. How do you prove that this lies on the line y equals x? In order for it to lie on the y equals x line, the two coordinates should be the same, right? For whichever value of x, you have the same value of y. For whichever value of t, over here, you have the same over there, right? So you have just proven that it lies on the line y equals x.